The Ten Tec Orion, the next step in amateur radio innovation. The Ten Tec Orion represents the most innovative HF transceiver ever created for amateur radio use. Our aim in designing and producing this radio was to meet the demands of increasingly intense competition in DX and contesting, while adding many non-performance related features that the active ham can also appreciate. The features and performance Orion brings to ham radio will enhance HF radio contacts of all sorts, while opening new possibilities for amateur radio operation. Orion offers world-class reception and transmission of CW, single sideband, digital modes, FM, and AM on all 10 HF amateur bands, plus excellent general coverage reception via the second receiver from 100 kHz to 30 MHz. I'm Scott Robbins W4PA, the Amateur Radio Product Manager for Ten Tec. This is our Orion demonstration video. It'll consist of 3 parts. The first, a general overview of the transceiver. The second, some detailed information on the various functions and features of the rig. And third, some specialized information about setting up the rig for weak signal DXing, contesting, single sideband transmit audio, and a few other features on the rig. The Orion is built around two 32-bit floating point ADI Shark DSP processors. Using dual 32-bit devices provides much more processing horsepower than a transceiver using a single 32-bit DSP processor can provide. The result is unparalleled HF receiver performance, filtering, and flexibility. The Orion features full dual receive capability. An amateur band's only main receiver, 10 through 160 meters, utilizes crystal roofing filters and IF-DSP bandwidth filtering. The subreceiver is IF-DSP and is general coverage from 100 kHz to 30 MHz. Both receivers can be used simultaneously on any frequency with no compromise in performance. The 2 receivers can share a single antenna, or each can be fed to a separate antenna. Bandwidth, AGC, PBT, high and low cut, AF and RF gain, attenuator, DSP noise reduction, and notch are all selectable independently on each receiver. 590 receive IF-DSP bandwidth filters are independently selectable on each of the main and sub receivers. The main receiver also accommodates up to 7 crystal roofing filters in the first IF stage. 4 of the 7 roofing filters at 20, 6, 2.4, and 1 kHz are standard, while optional filters are available at 1.8 kHz, 500 Hz, and 250 Hz. These filters can be cascaded with any of the 590 selectable IF-DSP bandwidth filters. The subreceiver has its own set of 590 bandwidth filters that are selectable independent of main receiver filtering. Very high receive intercept points, superior dynamic range, and an industry-best extremely low phase noise synthesizer make Orion's main receiver performance unmatched by any other HF transceiver. Programmable AGC response time is available on each receiver. Conventional AGC settings of off, fast, medium, and slow are provided, but the new programmable mode is groundbreaking. Users may build their own personal AGC characteristic by selecting threshold, hang, and decay rates. More than 1 million possible AGC combinations can be selected. Each receiver retains its own programmable setting. The Orion features true diversity reception using both receivers. Both receivers can simultaneously be fed to 2 separate antennas on the same frequency and controlled using a single VFO tuning knob. Superior low-band DXing capability using 2 separate receive antennas on 2 receivers and transmitting on a third TX antenna is possible. 3 antenna connections are provided, 2 SO239 connectors for transceive or receive antennas, and a third RX-only phono connector on the rear. The Orion features a continuous real-time spectrum display that allows monitoring of nearby band activity. 5 selectable sweep ranges allow user-definable limits to the amount of spectrum being monitored. The Orion is equipped with dual noise blankers, both a traditional style analog noise blanker and an IF-DSP noise blanker with a 9-stage selection control are provided for suppression of line noise and other pulse type EMI. 9 adaptive DSP noise reduction filters let you select the right amount of noise reduction for elimination of broadband hiss, noise, etc. DSP automatic notch filtering is also provided for automatic filtering of interfering carriers in single sideband modes. A manual notch filter is also provided with greater than 60 dB of cut and with an adjustable width feature. Both a voice keyer and CW memory keyers are built in. You can program up to 3 voice messages and up to 3 CW messages for playback by pressing the Send 1, Send 2, and Send 3 buttons. Like the Jupiter and Pegasus before it, the Orion is flash ROM updatable. To obtain the latest version of the Orion, simply visit our firmware download website. Connect Orion to your computer via a serial port cable and send the software over to the radio. It's that easy. The second part of our video presentation on the Orion will consist of a detailed description of the features and functions on the transceiver. 2 columns of antenna selection keys allow the assignment of up to 3 connected antennas to each of the 2 receivers. The most common arrangement would be to have a single antenna connected to antenna 1 used by either the main receiver only or by the main receiver and the subreceiver both. When either the antenna 1 or antenna 2 buttons in the main RX-TX column is lit, a receive-only antenna can be substituted for the receive side of antenna 1 or antenna 2 by pushing the appropriate button. 3 buttons control the assignment of the subreceiver to each of the antennas connected to the radio. The subreceiver can either share the same antenna in use for the main receiver, or it can be split off for use with a separate antenna. The 2 large tuning knobs on the Orion are for each VFO. Regardless of receiver assignment, the large knob on the left closest to the screen is always VFO A, the large knob to the right is always VFO B. Next to the frequency display for VFO A are the letters T, R, and S. T is for transmitter, R is for main receiver, and S is for subreceiver. As the operator assigns the transmitter and receivers using the buttons on the VFO control pad, the T, R, and S indicators move back and forth across the screen to allow the operator to know where he is transmitting or receiving. The main receiver and the transmitter are amateur bands only coverage. An attempt to assign them to a frequency outside the ham bands will result in one of 3 messages appearing on the screen: VFO A outside RX range, VFO B outside RX range, or frequency not supported, depending upon how the user was attempting to put the main receiver on a non-amateur frequency. The power button is used for setting RF power output. Press the power button and then turn the multi-knob to adjust the value between 1 and 100. The value set from 1 to 100 will roughly correspond to power output in watts, but this will vary a few watts depending upon band and load impedance. Orion is equipped with a transmit audio monitor to allow the operator to hear actual transmitted audio. Transmit equalization, speech processing, transmit bandwidth, and low frequency roll-off all have an effect on the sound of the transmitted SSB signal, and to properly adjust these controls for no distortion and desired sound, use the monitor. The volume of the monitor level is expressed as a value from 1 to 100% of available. Monitor is available through either headphones or via the speaker. The monitor function is also usable in FSK mode for monitoring of transmitted tones. The SP button has 2 different functions depending upon which mode the operator has selected. In single sideband modes, the SP control is used for speech processing. In LSB or USB mode, press the SP button to turn the speech processor on and off. When on, use the multi-knob to adjust from a value of 1 to 9. Higher values represent more processing. The SP button is used for keyer speed control in CW modes. Press the SP button when in LCW or UCW mode to activate the CW keyer. I'm going to demonstrate the use of the Send 1, Send 2, and Send 3 functions on the Orion. In voice modes, they're used for voice keyer memories. In CW mode, they're used for CW keyer memories. To record a voice message, you press and hold the Send 1 button. A menu will appear entitled Digital Voice Recorder Control. To record a message, you press the record button while holding the PTT on your microphone. CQDX from Whiskey 4 Papa Alpha. Press the stop button at the end of the message. Then you can listen to it back by pushing the play button.
CQDX from Whiskey 4 Papa Alpha.
Now I'll demonstrate how the Send 1, Send 2, and Send 3 functions work in CW modes. Press and hold the Send 1 button. Press the record button. And then start your message. Press stop when done, exit, and then to play your message on the air, press the Send 1 button. The Orion is equipped with a total of 5 user profiles. User profiles are like a super memory. Everything on the radio, all settings, all menu selections, everything will be saved to a user profile memory. These are different from traditional memories that save frequency, mode, bandwidth, and maybe 1 or 2 other parameters. The User 1 and User 2 buttons allow saving and recalling of user profile number 1 and number 2. User profiles 3, 4, and 5 are accessible through the menu system. To save a user profile in either User 1 or User 2, just press and hold the desired button. You can see that said storing parameter set number 1 and then store complete. Now I'm going to change a number of the things on the radio. To recall the original radio configuration, all I have to do is press the User 1 button, and after about 5 seconds, it'll bring the radio back to its original state. And now the radio is back where we started when we saved the memory. The Recall button allows access to User 1 and User 2, as well as profile memories 3, 4, and 5. Number 5 is also a factory default setting that returns the radio back to all factory default settings on the radio without having to do a master reset. You press and hold the Recall button. You can see the first one shown here is factory defaults, and then I'm turning the multi-knob to show number 1, number 2, number 3, and number 4. The Recall button is also used to access the traditional memory system in the Orion. There are 2 buttons located between the 2 main tuning knobs labeled VFO-A to memory and VFO-B to memory. To save a memory, you press the VFO-A to memory button. You can now see on the screen that it reads Memory Store, and by turning the multi-knob, I can select any memory channel. For example, we'll store this in number 5. I'll press VFO-A to memory here, and it's now been stored in memory location number 5. To recall it, I press the Recall button, and you can see it's 2100500 mode LCW, ready for access. The Orion is equipped with a pair of noise blankers. One is DSP based, the other is a traditional analog style hardware noise blanker. You can see here above the noise blanker button that the screen currently reads 8:H. The H indicates the hardware noise blanker is in use. The 8 indicates the level of DSP noise blanker that's currently in use. The hardware noise blanker is turned on and off by holding the NB button. You can see the H now went off. The multi-knob is used to adjust the value of noise blanker, with higher values being more aggressive on unwanted noise. These noise blankers can be used together in tandem or separately. The Orion is equipped with DSP Noise Reduction that's independently adjustable for each receiver. There are 9 different settings, and each of the 9 are used to determine how aggressively or quickly the noise reduction system adapts and identifies what is signal and what is noise. We've got the noise reduction set on a value of 3 at present. We're on a frequency where no signal is present. Now I'll turn the noise reduction off, then back on. You can hear there's a pretty dramatic difference between no noise reduction and the noise reduction system for just listening to noise. For a real-life example of how the automatic notch and manual notch filters work, we're going to go up to 40 meters and find a broadcast carrier. Okay, you can hear the carrier there. You can notch that out automatically by pushing the AN button. The multi-knob will allow you to select automatic notch in several selectable ranges. This is a fairly weak carrier, so it doesn't take much to notch it out. Manual notch works much the same way. You have a center frequency. It's adjustable with the multi-knob. This carrier's down around 500 hertz. The width is the total system bandwidth of the notch, and you adjust center frequency and width to be able to notch the offending carrier out. Changing modes on the Orion is accomplished by pressing the Mode button. A mode menu then showing the available modes appears on the screen, and you press the corresponding button next to the mode to change it to whatever mode is desired. The Orion main receiver is equipped with a 12 dB gain preamp that's selected on and off by pushing the preamp button. The RF gain control is adjusted on the Orion by pressing the RF gain button and then turning the multi-knob to adjust the value. To demonstrate the CW spot and CW offset function, I'm going to tune down to the CW portion of the 40 meter band. The spot function is used to set CW offset. You press and hold the spot button and then adjust the multi-knob for whatever your desired CW offset is. Once you have it set, you then match that tone to the tone of a received CW signal to be 0 beat. The Orion has 7 selectable step sizes for each receiver, and each receiver is adjustable independently. By pressing the step button, you then can see 7 available choices: 1 Hz, 10, 100 Hz, 1 kHz, 5 kHz, 10 kHz, 100 kHz, and you select the step size just by pushing the button next to it. The main receiver on the Orion is equipped with a real-time band sweep display. It's turned on and off by pressing the sweep button here. You can see signals on the sweep scope at the bottom and tune toward them. The sweep range is adjustable in 5 different increments to a maximum of 72 kHz. The Orion has 5 selectable AGC settings that can be selected independently for each receiver. The available options are programmable, off, slow, medium, and fast. We'll discuss the programmable AGC in detail later in the video. The Orion is equipped with a receive attenuator that can be selected independently for each receiver. There are 4 selectable steps of off, -6 dB, -12 dB, -18 dB of attenuation. To activate, press the attenuation button. The Orion has a series of 7 user menus that are accessible by pressing the Menus button on the transceiver. We'll discuss these menus in detail later in the video. As an option, the Orion may be equipped with an internal automatic antenna tuner. To access the auto tuner, press the Tune button. After approximately 2 seconds, the tuner will tune and the legend "Tuned" will appear on the radio screen. The MIC button is used for adjusting mic gain. Turn the multi-knob to adjust. S-tone is CW side tone volume, again turning the multi-knob to adjust. And Vox is for enabling or disabling Vox operation in single sideband mode. The Orion has 2 audio sources, the main receiver and the sub-receiver, and 3 potential destinations for the audio: through the speaker, through the left side, or through the right side. The left side output is both headphone and line level audio accessible from the back, as is the right side. To route audio, you press the audio menu you see here. Main receiver audio is currently being routed to the left headphone and the left output for line level audio on the rear panel. Sub-receiver audio is currently being routed to the right headphone and the right line level output on the rear panel. And the speaker is receiving audio from both receivers. You can change these merely by pushing these buttons here: main, sub, or now you can hear both receivers in the left ear; sub, both receivers in the right ear; speaker, the same thing: main receiver, sub receiver, both receivers through the speaker. Panoramic stereo receive is accessible by pressing this button. Panoramic stereo receive essentially allows you to tune across a CW signal and hear it in stereo spatially move from left to right as you tune across the center frequency. We'll go into detail on that a little bit later and give an example. TX-EQ, RX-EQ, and sub-EQ are equalization controls that are 6 dB per octave filters. The TX equalizer is accessible by pressing this button and then adjusting the multi-knob. Same with main receiver equalization and sub-receiver equalization. As I've been describing, many of the receiver functions on the Orion are controllable per receiver rather than having a specific function adjusted for both receivers simultaneously. There are 2 buttons that are located between the main tuning knobs of the Orion that allow that, the main RX and sub-RX buttons. All these buttons do is allow you to adjust features for either the main or the sub-RX. When you have the sub-RX button selected, you're adjusting step size, AGC, etc. over next to the screen for that receiver. When you press main RX, you're doing it for the main receiver. Additionally, when you press the main RX or sub-RX buttons, you can make them jump to the next main tuning step size. If you have the main receiver, for example, set for 10 Hz steps, you press a lit main receiver button again and it jumps to 100 Hz steps. Press it again, it's back to 10 Hz steps. This allows for quick excursions up and down the bands. Let's talk about the receiver filtering system in the Orion for a moment. The receive filtering in the Orion really is what sets it apart from transceivers we've built in the past or that the Japanese companies have built. The difference primarily being that we use mode-appropriate roofing filters as part of the Orion's receive system. The usual pitfall for top-notch performance in a modern HF receiver is the use of a 15 to 20 kHz wide roofing filter at the first IF stage. This wide filter will allow unwanted signals outside of your receiver's passband to compromise receiver performance. By using crystal filters as selectable roofing filters at the first IF, undesirable signals are kept out of the receiver chain and do not compromise close-in receiver performance. Any signal that appears inside the roofing filter, even if you don't hear it in your receiver passband, will have a negative impact on receiver performance. Loud signals inside a roofing filter lead to a loss of dynamic range and receiver sensitivity. We've been able to overcome this with the Orion by using a series of mode-appropriate roofing filters. There are 7 filters total available. 4 of the 7 are standard at 20 kHz, 6 kHz, 2.4 kHz, and 1 kHz. Additionally, with optional filters available at 1.8 kHz, 500 Hz, and 250 Hz. Orion's roofing filters are not to be confused with traditional crystal bandwidth filters. For bandwidth filtering, Orion has 590 built-in DSP filters from a minimum of 100 Hz to a maximum of 6 kHz. The use of mode-appropriate roofing filters at the first IF, combined with IF DSP filtering at the third IF, produces receiver performance specifications that are significantly better than any other transceiver on the market to date. The passband tuning and bandwidth controls share a common encoder, and you can select between PBT and bandwidth by pressing the encoder inward. You can see that now that it has selected PBT. Both passband tuning and bandwidth are represented by a graphic on the screen and a numerical value. You can see as I adjust PBT here, we're going up, past center, and down, and the filter moves. Same with bandwidth. The filter gets larger. As I move downward, it gets smaller. PBT and bandwidth are selectable in 10, 50, or 100 Hz steps, and the control for changing it is located in the menu system. The high-cut, low-cut control is both a passband tuning and a bandwidth function. Unlike traditional passband tuning, which moves the filter back and forth across a given center frequency, high-cut, low-cut allows you to move one side or the other of the filter in towards center without moving the other side inward or outward. You can see the passband tuning moving back and forth and the bandwidth moving back and forth as I move this control. Again, just like passband tuning and bandwidth, you press the encoder to switch back and forth between the two available. The multi-knob shown here is used for control of a variety of transceiver functions. The Orion has separate audio controls for each receiver, main AF and sub-AF. To increase the audio gain, turn the encoder. To mute receiver audio, merely press the encoder in toward the front panel. Additionally, there's a graphic representation of both of these on the screen itself. You can see by the bar graph over here on the left that the audio gain is turned up halfway and only half of the scale is showing. That indicates that the volume is at about half level and is muted. When I turn the main AF knob, the audio comes back at the level it was at previously. Press again, and the audio is muted. The same applies to the subreceiver. Turn the encoder to increase audio gain, and press to mute. Orion is equipped with 4 band stacking registers per band that will retain frequency, mode, and receiver bandwidth. For example, when already on 40 meters, press the 40 meter button to go to the next band stacking register. You can see that mode, bandwidth, and frequency have changed. We go to the 3rd one, the 4th one, and then back to the original band stacking register. There are 4 registers per band available. The band change keypad is also used for direct frequency entry. You can direct frequency enter into either VFO-A or VFO-B by pressing the appropriate enter button and then entering the frequency on the keypad. Additionally, the optional Model 302R remote encoder keypad will allow you to do direct frequency entry right from its keypad. The AB, BA, and A/B buttons on the band change keypad allow for the exchange of frequency information between the 2 VFOs. Press the A/B button to exchange the 2 frequencies. Press A to B to copy the A frequency to B. And then press B to A to copy the B frequency back to A. Via the menu system, the Orion has a number of user configurable settings that allow the user to customize the transceiver for his or her particular operating style. To access the menu system, press the Menus button located to the upper right of the radio screen. A menu screen will appear. There are 7 selectable menus accessible after pressing the Menus button. To the right side of the screen, there are 7 choices: TX, CW, Vox, RX, Other, SSB, and Filter. Each of these menus can be accessed by pressing the corresponding button next to the right edge of the screen. For example, I've just selected the TX menu. The TX annunciator on the screen is highlighted and the menu options for TX are shown in text on the screen. In each menu, to scroll through the available choices on the screen, turn the large main tuning knob closest to the radio screen. For each line item, to change the values, turn the multi-knob. To exit the menu system and return to radio operation, press the Menus button again. One of the most useful and revolutionary new features of the Orion is fully programmable AGC. AGC action can be programmed to taste on each receiver for fast, medium, and slow settings, and a 4th setting, programmable, allows the user to adjust any and all of the AGC characteristics. Hang, decay, and threshold parameters for each are fully adjustable. For fast, medium, and slow, the hang and threshold parameters are fully adjustable. AGC hang is the amount of time that the AGC remains actuated before decay begins. The threshold is the point at which a signal of a given strength, expressed in microvolts, will actuate the AGC system. The threshold value in the AGC system acts like an IF gain control for the receiver chain. Turn the value low and receiver gain comes up, as do signal levels. Decay is used to determine how fast the IF gain increases in the absence of a signal above the threshold value. The hang value for fast, medium, and slow is adjustable from 0 to a high of 10.92 seconds. Threshold value for fast, medium, and slow is adjustable from 0.37 microvolts to 198.48 microvolts. The decay values available are fast, 80 to 200 dB per second, medium, 20 to 80 dB per second, and slow, 5 to 20 dB per second. The programmable AGC setting allows full adjustment of all parameters in the AGC system. In addition to the hang and threshold values being fully adjustable as they are with the fast, medium, and slow settings, the programmable AGC setting allows the decay rate to be adjusted over its full range from 5 to 2000 dBs per second. The main tuning knobs on the Orion both feature an adjustable drag control. To adjust the drag on the tuning knobs, grab the knob, holding the metal skirt, and turn either direction for either maximum or minimum drag. Part 3 of the Orion video presentation will feature some real-life examples of how to use the radio on the air. First, we'll cover basic transceiver operation. Typical transceiver operation would be to have the main receiver and the transmitter on VFO-A and the subreceiver on VFO-B. The audio menu determines the mix of main receiver and subreceiver audio heard through the speaker or the headphones. Antenna selection is determined by the matrix of 6 buttons at the far left of the transceiver. Split frequency operation with the Orion is a snap. You can see here that we have transmit and receive set on 14.195 and the subreceiver on 14.215. To transmit on the subreceiver frequency, merely press this button. You can see the T icon has now moved down to 14.215. You're now transmitting on 14.215 while listening with the main receiver on 14.195 to the DX station. You can now monitor both sides of the pileup on 14.195 and 14.215 while transmitting split frequency. One of the features of Orion is a lot of flexibility afforded the operator for the desired sound of single sideband transmit audio. Many possible settings are available so that operators with different styles or philosophies can adjust the radio the way they want it to sound. Obviously, the operator who favors full, rich-sounding transmit audio is not going to have the same needs as the DXer who wants maximum oomph to try to break a DX pileup. There are 5 radio controls used for adjustment of single sideband transmit audio. The first is transmit bandwidth, which is adjusted using the TX filter bandwidth control in the SSB menu. I'm going to go to the microphone now and listen to monitor audio.
Okay, I'm now talking through the radio. We've got TX filter bandwidth at 2100 hertz, and as I narrow this down, you'll hear the audio get quite restricted. As I widen this out, the sound of transmit audio gets a whole lot more pleasing to the ear at a maximum of 3.9 kilohertz. I'll narrow this back down to about 3000 hertz. The next control is low frequency roll-off. This determines where at the low end the audio response of the transmit envelope starts. We'll have it at 100 hertz here, and I'll move it up to maybe about 200. This will give us a total audio bandwidth of 200 hertz at the low end, 3200 hertz at the high end for a total of 3 kilohertz filter bandwidth. The next control is TX equalization. I go to the audio menu here. You can see here on the screen that TX EQ is at 0 dB, which is flat. I'll now turn this up, and you can hear the bass response of the audio increase as I go higher. As I go back downward towards 0 and flat response, it gets a little more trebly until I go down here like this, and it's a whole lot more treble. So for my particular voice and the Ten Tec 706 desk mic, it sounds pretty good with about 4 dB or so. I'll leave that there. The other 2 controls are mic gain, which you see here. That can be adjusted for proper ALC action. You can see the ALC light flashing as I am talking on voice peaks. The other sideband control is speech processor. You can see at the moment it is turned off. I'll press the SP button. It's now at a value of 2, which just is a little bit of speech processing. You'll hear as I increase the speech processor that we're getting a little more distorted. We get up here and it's quite distorted. I guess you could call this DX mode. As we go downward, it gets a little more pleasing to the ear. And I'll leave it at about a setting of 1. So you can see with a speech processor setting of 1, mic gain about 53, a little bit of TX equalization, filter bandwidth at 3000 hertz with low frequency roll-off at about 200. That gives a pretty good sounding SSB signal for me.
The same factors that affect SSB transmit also come into play for AM transmit operation as well. Put the radio here in AM mode. Speech processor, low-end roll-off, TX bandwidth, mic gain, and TX-EQ are all used for AM operation as well. Transmit bandwidth in AM operation is doubled from that shown in the SSB menu. To select a 6 kHz AM transmit bandwidth, select 3000 Hz in the SSB menu as the transmit bandwidth. Carrier amplitude for AM operation is set automatically by Orion. A value of 100 would correspond to 100 watts PEP AM output or 25 watts carrier power. Selection of FSK mode will allow the Orion to operate true FSK radio teletype. The FSK circuitry is controlled through the rear aux I/O jack on the rear of the Orion. The Orion receives FSK using lower sideband. The center of the filter pass band is preset, so any bandwidth filter used will be centered on the standard FSK mark space tones. The Orion display indicates the transmit mark frequency. There is also a user-controlled called FSK TX data in the other menu for selecting whether the mark is the low tone or the high tone. This allows the Orion to be used with either TTL or open collector keying schemes. The monitor function is available in FSK mode and may be used to monitor the transmitted tones. Ten Tec has a new unique panoramic stereo receive feature as part of the Orion. This allows you to tune across CW or signal sideband signals and actually hear the signal move back and forth spatially in your headphones as you move across the center frequency. It's referenced to on CW to the spot frequency you have set of 700 Hz in this case. I'll go into the audio menu and turn on Binaural Receive. It's now active on the main receiver. Now as I tune across the CW signal, you'll hear it move from left to right through the headphones. Through the center, and then off to the side. Then we'll tune back again, back across the middle, in the middle, and then as we tune past it, it goes out through the right side headphone. Because the Orion has the ability to have both receivers tuned by a single VFO simultaneously, and because both receivers can be split out to different antennas, a world of possibilities for diversity reception are opened. Diversity reception is radio reception in which a signal is obtained by combining or selecting signals from two or more independent sources, but may vary in their fading characteristic at any given instant. Good examples would be the use of one horizontal and one vertical antenna, or two horizontal antennas separated by one wavelength or more. It's been shown from studies that weak and/or fading signals are more copyable when they are heard from two sources simultaneously rather than only one. Because Orion allows you to tune two receivers with one VFO, diversity reception is possible using the two receivers on two separate antennas. First, we'll want to put both receivers on a desired frequency. You see we have both of them here on 14.209 at present. We can now put both receivers on VFO A. You can see here we have TR and S. That indicates transmit, receive, and sub, with these three buttons are selected. And now with the VFO A knob, I can tune both receivers up and down the band. Both receivers are presently on one antenna. I can now split the receivers out to two separate antennas. In the audio menu, I have left side audio from the main receiver, right side audio from the subreceiver, so I'm actually listening to each receiver on a separate antenna in separate ears. Now I could, if I chose, route both receivers to both ears. Now we have sub and left and right, both in both ears. Now I'm tuning across the signal and I'm listening to both receivers in both ears on separate antennas. Let's talk about weak signal DX reception and contest operation in the Orion. With recent transceivers, an operator typically would set CW for a low or comfortable offset, select a narrow bandwidth filter like 250 Hz, turn AGC to either fast or off, and use some setting for DSP noise reduction to start listening for weak signals, which is fine, except that typical settings like this used for other radios may not use the Orion to its maximum capabilities. If you set a transceiver for one optimal setting to use it for variable conditions, would it seem logical that the operator would be using the transceiver to its optimum capability each and every time? Perhaps nothing is more important than AGC setting, and for single signal, weak signal DXing purposes, The programmable AGC value is probably the most valuable tool on the Orion. If I press the menu button here, we can go into the RX menu. You can see that hang, decay, and threshold times for both the main and sub AGCs are variable. There's a couple of different methods you can set programmable AGC for optimum performance for weak signal DXing. For the first example, we'll set hang time at 0. We'll call this quick decay variable gain. You can set the decay at perhaps 60 dB per second. Set the threshold at a fairly low value. In this case, we've got it at 1.01 microvolts. As you increase the threshold to higher values with the multi-knob, it is possible that a weak signal will come out of the noise as the system gain decreases and the AGC no longer clips the weak signal and noise. You can hear there's a fairly weak signal on this frequency. What I'll do is turn the multi-knob to adjust the threshold and see if we can make him a little more readable. You can see we've now increased the signal to noise ratio by backing the gain down just a little bit and having that signal come up out of the noise. This is about an S2 signal on the S meter at the moment. The effect is even more dramatic on a signal down at the noise floor level. The other method for adjusting AGC would be the low threshold varied decay method. You can set the threshold to a low value to maximize gain. Turn this down to about 0.80 microvolts. You can then use the decay control to adjust starting from a slow setting. We'll start at 5 dB per second, which is the lowest, and working upward. As decay goes faster, it introduces clipping, and you'll hear that. You can hear how that signal, now there's a louder signal, it's a little bit distorted. Down here in the lower decay ranges, it's not nearly as distorted as on the higher. What you want to do is advance the decay until the point where the noise and the signal starts to clip a little bit and then back it off. Why this is advantageous is with traditional AGC systems, typically on a setting of medium or fast, there is no adjustment and you may already be at a level that is clipping noise. If you're trying to listen to a weak signal with a fixed AGC setting that is introducing noise clipping, it's also going to clip the signal that's mixed in with the noise. That all being said, you can have a set it once and leave it value for programmable AGC for weak signal DXing. If you set the AGC hang at 0, as we have here, set the decay at approximately 40 to 60 dB per second, and run the threshold value to a low setting around 0.5 microvolts or so. This ought to provide a good enough combination of settings to allow just about anything that is audible to be detected by the radio and likely copied as well. If you need a little bit more, you can always go in and change the AGC parameters for a given situation as we've just described. Contest operation is a little bit different. Generally, contesters are not going to want to be fiddling with controls during the course of the contest like DSP Noise Reduction, AGC, etc., unless it's to quickly adjust some parameter for a given situation. The needs of a contester are a little bit different. They need the radio to be set for a somewhat optimum set of values to meet these criteria. The ability to copy both weak signals and loud signals with AGC good enough to minimize the output variability between the two, the minimization of loud nearby signals having an effect on overall receiver performance, and having a reasonably optimum start setting that will keep the operator from having to constantly adjust controls on the radio. Now, these goals are not common to single signal DXing. At first thought, it would seem that what would be good for single signal DXing would also hold true for contesting, and perhaps for previous transceivers there was an element of truth to that. Actually, though, what would be good for copying a varying ratio of signal strengths under crowded band conditions is not at all the same as copying one weak signal with a beverage receive antenna under quiet, non-contest conditions. So we can have some recommended start settings for contesting, for example. In the filter menu, we can set the crystal filter to automatic. This will bring in the desired mode-appropriate roofing filter automatically as you adjust the DSP bandwidth filter settings across the value of the roofing filter. It's likely during a contest that loud signals are going to be present nearby, and minimizing them as a factor in overall receiver performance is paramount. This is where every other transceiver fails under contest conditions. When you have an S9 plus 30 dB CQ or 3 kHz up the band, It's having a significantly negative effect on a transceiver that has a 6 kilohertz or a 20 kilohertz roofing bandwidth. The Orion has no negative reaction to the same signal. You could set, for example, the roofing filter to 500 hertz and signal 3 kilohertz away would have no effect whatsoever on the radio. This helps preserve receiver performance down to the smallest available bandwidths. Setting programmable AGC value is a little more tricky for contest operation. Obviously, you want a good amount of gain through the system, but limit the ability of strong signals to blast the operator in between listening to the weak ones. Setting the AGC hang value again to 0, a good starting point for the threshold value would be approximately 1 microvolt, with decay at a somewhat slow value to prevent signal clipping of the weak ones as noted in weak signal de-Xing adjustments for programmable AGC. This will allow good copy of weaker signals but allow the AGC system to compress loud signals and give a reasonably uniform signal output for both weak and loud signals. Thanks for watching our video presentation on the Orion. To contact Ten Tec, call us at 800-833-7373 or visit our websites at www.tentec.com or www.rf2.com. I'm Scott Robbins W4PA, 73 from all of us at Ten Tec.